Okay, first thing we talked about was basically a review of Science 10. Okay, we talked about scalar quantities and vector quantities. Okay, we said scalar quantities are things like time, distance, speed, energy, work, although these two things aren't in this unit, but we mentioned them as scalar quantities. Okay, so time scalar, distance is scalar, speed is scalar. Okay, we talked about vector quantities, displacement, velocity, acceleration. Okay, those are all vector quantities. Force, that's the next unit, but it's also a vector quantity. Vector quantities have both magnitude and direction. Right? There's probably a few multiple choice questions on the exam about that stuff. Okay, those should be pretty easy multiple choice questions, like which of the following is a vector quantity, or vice versa. Okay, or vector quantities have A, B, C, D, magnitude, direction, both, neither, whatever. Okay, something like that. Okay, expect that kind of stuff that's just recall to be tested in the multiple choice section. Okay, simple use of V equals D over T. All right, we reviewed that. We know how to do it. It's part of projectile motion. Okay, but will there be a 5-mark problem-solving question in the written response about V equals D over T? No. Right? There might be a simple calculation on V equals D over T in a multiple choice question. Right? Just because, well, that stuff's pretty easy. Okay? It's not worth a big problem-solving problem in the written response part. Okay. So you could have something like so-and-so walks this far west and then they walk this far east and it takes 10 seconds. What's their velocity? Okay, so there's just collinear stuff, easy V equals D over T kind of calculations. All right, so everything there in number 1, multiple choice. Okay, but do remember that this is also part of projectile motion. Okay, you do have to use that. You do have to use that for the horizontal, right? For the horizontal part of projectile motion. Okay, graphing. All right, so we talked about velocity versus time graphs here just a minute ago when we went over the acceleration lab, but position versus time graphs are also on here. Okay, so expect that there are going to be several graphs. There's a couple in the multiple choice, and there's one of each in the written. Okay, the expectation is that you can use that. Okay, if you have a linear graph, okay, that's one that looks like either of these, it's just one line, you'll probably get that. Okay, I'll put it somewhere on the graph. If you see this equation on the graph, should it be used? Most definitely. Okay, I would not put the graphing equation on there with the numbers in it. Okay, with obviously M and B in there. Okay, I wouldn't put that on there if I wasn't expecting you to use it in some way. Okay. With all questions, kind of general pointer, make sure you look at the point value. Okay, I always put the point value in brackets at the end of a question. If it's 1 mark, how much calculating does it require? Actually, none. Okay, if it's only worth 1 mark, it's not even not much calculating. It's literally the answer is right in front of you somewhere. Okay, it's a matter of can you recognize where the answer is? That's that kind of a question. If it's only out of 1 mark, it's just a mark for the answer. Okay, if it's out of 2 marks, then there's very little. Okay, if it's out of 3 or 4 or 5, then yeah, you probably got manipulating and plugging and stuff like that. Okay, so always be on the lookout for that. Okay, because I've had people who spend like 6 minutes showing me 10 marks worth of work for a 1 mark question. Okay, if it's a 1 mark question, all you should be writing down is an answer, like a simple, probably just a number with units, possibly direction. Okay, if it's vector, that's it. Everyone follow on that? That's kind of a big tip for any exam. All right, so for velocity versus time, okay, like we said, we talked about area underneath the line is calculating displacement. Slope of the line is calculating. Oh, please. We just talked about it. Slope of that line represents acceleration, right? Okay, we got it. That's the stuff we got to know, guys. Okay, position versus time graph. Okay, we can calculate displacement, final position minus initial position from that graph. What does the slope of this graph represent? Since I'd be dividing the change in position by the change in time. Lucy, what would it represent? Okay, better figure it out by Monday. Change in position is displacement. Agreed? What's displacement divided by time? Velocity. Slope of that line is velocity. Okay. I think you guys have a lot of studying to do this weekend. I was really quite honestly expecting this stuff to be pretty automatic by now. So I'm now more concerned than I was when I came here this morning. I hope you are too. Okay. Okay. Problem solving for acceleration. There's going to be, for sure, there's one problem solving question. So here's like a written word problem like was on your worksheet on acceleration. And there's one 2-mark bonus question, and it's an acceleration question. Should you do everything else on the test before the bonus question? Okay, please. I had a kid once who started on the bonus question, didn't finish. Okay, don't do that. Don't do that. Okay, all right. No, he didn't get it either. That was the worst part. Okay, vector addition problem solving, definitely. Okay, there's one fairly large vector question, very similar to what you've seen on your quizzes. So good idea to look over quizzes on the weekend. Yes. Okay, remember you go into Power School, look at your quizzes. You can click on them. When you do, there'll be a link to the questions and a link to the podcast of me solving it. Okay, so there'll be 2 links in every task. Okay, you can go and see, try them again, and then see if you did them right by watching the podcast of me solving the questions in class. All right, so that's a good way to study as well. All right, so there'll be some vector addition questions. Remember that we always add our vectors tail to head. Okay. Draw the x and y components, solve for x's and y's. Okay. Boat question. Boat in a river question, definitely. Okay, so you got a vector question and a boat question. All right, so there's going to be a boat in the river question. All right, we talked about those when we went over your vector assignment the other day. That was questions 9 and 10. Okay, they were boat questions. The one on the test will be very much like those. Right, just like 9 and 10. Okay, and then projectile motion, problem solving. There's one of each in the written response. There's a projected at an angle. Oh, excuse me. Projected at an angle and projected horizontally. One of each. Okay, very much like the questions we did in class. Okay, like I would say, especially look over the general E question and the buffalo question from yesterday. Okay. On your multiple choice form, okay, have a pencil. Okay, you got to have a pencil for Monday. Okay, you're going to be using, how many people have used the zip grade forms before? Okay, that's what I use. Okay, I can mark it with my phone. The camera takes the picture, it marks it, right? Keep in mind that I have a picture of your original test because I once had a kid who fixed a whole bunch of his answers and then came back to Mr. Coderre, it marked it wrong. And I went, oh, really? Yeah, that won't work. I have a picture of your original test, just so you know. Okay, not that any of you would try that, but okay. So what you need to do though is make sure that you don't do that, because oh my God, I see that so often. Okay, someone goes, okay, yeah, it was this one, and they fill it in, and oh no, it wasn't that one. It's this one. No, no, and then they write this one, and they put an arrow on there. You know what my camera says when it marks that? It's wrong. That's all it says. Okay, it doesn't know what that means. Okay, just fill in one bubble. Okay, just one bubble. That's all you need to fill in. Okay, just one. And I mean, it doesn't have to be in pencil, but here's the problem. If you have this situation and you've done it in pen, you're pretty screwed at that point. Okay, so make sure you do it in pencil so you can erase it completely. Okay. All right. So details about the test here. Okay, we got 17 multiple choice. Okay, there are 17 multiple choice questions. There are 7 written response questions plus the bonus question. Okay, so 17 multiple choice, 7 written response. I have all the formulas already on the front of the test, so don't bother bringing your formula sheet because obviously I don't know how much stuff you've written to yourself already on your formula sheet. So there is a formula sheet on the front page of the test. So like we said here, we got a projectile motion question projected horizontally. We got a projectile motion question at an angle. We have a boat question. We have an acceleration question. Okay, we have a graphing question, vector addition question, graphing question, 7. Okay, so 2 graphs, that's 1 position, 1 velocity. Okay, 2 projectile, 1 horizontal, 1 angled, 1 acceleration problem, 1 vector addition problem. Okay, and 1 boat question. Okay, for your multiple choice, like I said, it's mostly, there's a little bit of graphing stuff on there, but it's like recognition as opposed to calculation. So here's a graph, what's going on, or when does this happen, stuff like that. So it's interpretation of a graph rather than calculation from a graph. There's some stuff that kind of checks understanding of vectors and scalars and acceleration and some like of the fundamentals of projectile, but there's not a lot of calculating. Or at least if there is calculating, it's quite simple in the multiple choice. So the multiple choice should go fairly fast. Like realistically, it shouldn't, the multiple choice should take you like 15 minutes. Okay, you should be able to do more than 1 question per minute on average. Okay, probably even faster than that if you're really well prepared, right? So as a result, my recommendation and the way I have put the test together is that I have the written response first. Okay, I would suggest you do the written response first because if you get pressed for time, and I don't think you will, but if you do, then it's always easier to rush the multiple choice than it is to rush the written. Okay, there's way more marks in the written. There's only 17 marks in the multiple choice. There's 48 in the written. Okay, the test is out of 65. All right, questions from you guys? Anything you want me to review in more detail or just have questions about in general? Projected at an angle? Okay. Okay, we'll do one like this. Okay, so let's say we've got okay, so here's our kind of basic projectile motion projected at an angle type question. Okay, I have an object that's projected 30 degrees above the horizontal at 100 meters per second. I want to figure out 2 things, its maximum height and how far it travels horizontally. Okay, so as always, we want to break this up into its vertical and horizontal parts. Okay, the thing we have to remember, okay, well, there's a few things we have to remember. First off is that this side of this triangle here represents the constant horizontal velocity, and that this side of the triangle represents the initial vertical velocity of the projectile. Because obviously vertically, there's acceleration going on, so the velocity is going to change. So in order to calculate VI with this triangle, it's the opposite side. So I go sine of theta times 100, and that's going to be 50 meters per second, and that's positive. What do I have to remember about an object that lands and is fired from the same height? The initial and final have the same magnitude, but they have opposite direction. Okay? If we don't remember that, it's very difficult to solve these. We also know the acceleration vertically is negative 9.81 meters per second squared. All right, horizontally speaking, okay, v horizontal is going to be the cos of 30 times 100 meters per second. All right, so 86.60 meters per second. All right, so we've got that. I'm still trying to find horizontal displacement. What do I need? What formula did we say we use for horizontal all the time? V equals d over t. So what do I still need? Time. All right, can I get time with these three things? Okay, time equals Vf minus Vi over A. So that's negative 50 minus 50 over 9.81. So it's going to be like 10.1 or 10.2. Okay, so 100 divided by 9.81, 10.2. Okay, 10.19 seconds. All right, so 10.19 seconds. Now I can go back over here. D equals V times T. Okay, and so we'll take our 10.19 seconds and multiply it by the 86.6. All right, so this thing is going to travel horizontally 8.8 times 10 to the 2 meters. Okay, is that ringing a bell there on? I mean, basically every single one we did worked that way. Okay, we were trying to find the horizontal displacement. All right, if I want to find the maximum height, that occurs right here. What's VF at this point? 0. That's another thing we have to remember about projectiles projected at an angle. At the maximum height, VF is 0. If I'm trying to find the vertical displacement, this is the best formula to use. Okay, because I can solve it in one step, which on a test is important. Okay, while you could solve this with a couple of steps using other formulas, that's going to take longer. Okay, on a test, we want to be as efficient as possible. Okay, so I'm looking for D. So D will be VF squared minus VI squared over 2A. So that's going to be 50. Well, 50 squared divided by 19.62. All right, so it's going to reach a height of 1.3 times 10 to the 2 meters. How important will significant figures be? Very. Okay, I don't really have any tricks like I did on the vector assignment to do with significant digits, but if your significant digits aren't right on the test, you will lose a mark. Okay, so make sure that they're right. Is that good, Athena? I know I went kind of fast, but okay. Other questions, guys? Yep. Okay, so we'll say 6.0 seconds. That's all the information we're given. Okay, so if we have that information, what can we find right away? We can find V horizontal, right? Okay, so if we got V horizontal, that's just going to be D over T, so 120 over 6. Okay, should be 20, right? Okay, so 20 meters per second is our horizontal velocity. So now we know this side of the triangle is 20 meters per second. All right, vertically speaking, we know the acceleration is negative 9.81 meters per second squared. Okay, this is another, that math trick again, right? I wasn't told VI or VF. I don't have the angle, right? So I can't use trigonometry to get them. But I can do this. A equals negative V minus V over T. Remember that VF and VI are the same, but in opposite directions, right? This eliminates one of the unknowns because we know they're equal in magnitude, right? So we're going to have A times T equals negative 2V, and then if I divide both sides by negative 2, then I'll have V, and then I'll have this side, and I can solve for the angle, yeah? I would say that's probably not the way I'm going to ask it. All right, what else? I'm not going to give further information about the nature of the test, as I think I've already spoiled enough of it. Yeah. There's a question like that one, which is why I told you to look at that one. I'm not going to give further details about the test. Okay, anything else you want me to review, okay, or go over? Boat. Yeah. Do another boat question. Okay, the hardest part of a boat question is reading the question. Honestly, that's the hardest part of a boat question, is making sure you read the question correctly. Okay, you have to be on the lookout for whether the boat is rowing straight across or is ending up going straight across, because there's a difference. Okay, if I row straight across, do I go straight across? No. Okay, but if I end up going straight across, that means I rowed into the current a little bit, and that changes how I draw the drawing. Everybody follow there? So that's one of the things to look for in that question. Am I rowing across or going across? Okay. All right, let's say we're rowing across. So if we're rowing across, we'll have the current, and let's just say it's, I don't know, 2 meters per second. And my rowing speed, let's say 5 meters per second. All right, so the question could ask a couple of things. First thing it might ask for is, what direction is the boat going? Okay, and it might say relative to the shore. Is that important? Okay, where's relative to the shore on this diagram? Sorry, here's my resultant. That'll make it easier. Where's relative to the shore? Above or below? Below. It's this angle here. Okay, that's relative to the shore. This is relative to perpendicular to the shore, which is probably not how I would ask that because it sounds weird. Okay, but could I find this angle and then get that one? At just 90 minus, right? They're complementary. Okay, and that's easy. That's just these two sides. The question might also ask, what's the resultant velocity? Okay, if it does, what am I finding? And I'm just finding the black one, right? Pythagorean theorem, and I'm good with that. The question will probably likely ask, I probably didn't need to say both. It will ask, how far downstream will you end up? Or how long does it take to get across? You actually need how long it would take to get across to find out how far downstream you would get. So let's look at both. Let's say this river is 200 meters across. All right, so we'll calculate the resultant here as well, just so we have it. So all right, so this is 10. That doesn't seem right, but it is. Okay. All right, which one of those numbers do I use to figure out how long it's going to take to get across? That's 5. Yeah, I don't have any 3s on there. That's a 5. Okay, so we use the 5. Why do we use the 5? Because it's parallel to this one. I have to use this distance because that's how far across the river it is. This is how fast I'm crossing the river. This is not how fast I'm crossing the river. It's how fast I'm going across and downstream at the same time. Okay, I can't use that because I don't know how far that is. Okay, I just don't know. So I'm going to go 200 over 5. Okay, which is going to mean that's going to take me 40 seconds. Did I do that right? I think so. Pretty sure. Okay, it's going to take me 40 seconds to get across the river. What am I doing the whole time I'm going across? going that way, floating downstream while I go across. So the entire 40 seconds I'm in the stream, I'm moving at 2 meters per second downstream. Right? D equals V times T, so I'm going to end up 80 meters downstream. Okay? Was there anything like really mathematically difficult about that? It's all interpretation, guys. Okay? Both questions are all interpretation of the question. Right? You have to do Pythagoras, you got to do one simple trig calculation, and V equals D over T. Okay? That's it. There's no one part of that that is difficult. All right, what else? Which kind? Position or velocity? Okay. All right. Let's say that we got actually a slightly different graph than this. Let's. Okay, so let's say we have a velocity versus time graph, guys, that looks like this. All right, we'll say that this here is 5, 3, 4, 5, 5, 8. Okay, so here's what we got. Paying attention, guys. Okay, we're asked to calculate the displacement from this velocity versus time graph. All right, so what we need to do, if we want to find displacement, we need average velocity multiplied by time, which is the equivalent of finding the area of all these shapes. Because if it's a rectangle, that object traveled at a constant speed of 5 meters per second for 3 seconds, which means it went 15 meters. Right? I went average velocity times time, which happened to be also base times height for that rectangle. Then I have this triangle here. Okay, its velocity changed from 5 to 0, which means it went at an average of half of 5, which is why when we go base times height over 2, we get the displacement here, okay? Because 2.5 would be the average velocity between 5 and 0. Everyone okay with that? Okay, so we got 2.5 times 1, so this can be 2.5. Okay, so 2.5 meters in there. And then in this part here, we go from 0 to 3, and we do that in 1 second. Okay, so 1 times 3 is 3, divided by 2 is 1.5. But it's negative because it's below the line. All right. Then I have this triangle here that's 3 seconds long by negative 3 meters per second high. So that's going to be negative 9 meters. And then this one here is 1 second by negative 3 seconds. So it's also negative 1.5 meters. Okay, and then I have this triangle here that's 1 second. So it's basically the same as this triangle. So it's 2.5 as well. Okay, everybody all right with that? What do I have to do with all those numbers now? Okay, I got to add them up, but I got to remember that these ones are negative. All right, so I got 15 and another 5 that are positive for a total of 20 up. Okay, and then I've got 9 and another 3 that are down. So positive 8 meters would be my total displacement there. Okay, everybody all right with that? Okay, so that could be like the type of, or you could get one that's just a regular line like we went over on the lab. Okay, just all depends. Well, I can only do acceleration for the parts of that graph that are accelerating. So this is a case of I would use this formula now. Okay, like if it said, what's the acceleration between 3 and 5 seconds? I would use this, right? Because I can't use y equals mx plus b for this because I don't know what m is. I don't know what b is. Okay, I can't use it. Everyone follow? So that's a situation where on this type of graph, I would use this. If I have just one line and it's all linear, then I'd use y equals mx plus b. Okay, so here's a situation where this formula applies. So that's all I would do, is just an acceleration problem from there. Okay, so it would be -3 minus 5, so -8, and that happens over 2 seconds, so -4 meters per second squared. Okay. All right, other questions? Okay. The test rewards those who are well prepared. Okay, there's no doubt in my mind about that. Okay, if you are well prepared and you look at the stuff I've told you today, the stuff we've gone over today, that's the stuff that's on there. Okay, make sure you're prepared for that kind of stuff. All right, if you're waiting to study until Sunday night, you're screwed. Okay, I'm going to be perfectly blunt with you on that. If you don't open a book and start doing anything in preparation for this test until Sunday night, you're screwed. Go to bed and get a good night's sleep. Well, if you can sleep with that thought. Okay, but okay, you do need to do a fair amount of advanced prep for this test. If you do, it'll reward you. Okay, if you don't, then you're gambling. Okay, you need to know that. Keep an eye on the time. Okay, when I made up the key for this test, it took me, I think, about 18 minutes. Okay, now I expect that you guys are going to be between 3 and 4 times slower than me. Okay, kind of on average. Okay, if I can take whatever my time is and multiply it by 4 and still be under 85 minutes, then the test is fair. Okay, if I can only multiply my number by 3 and stay underneath, then the test is a little harder. Well, go 85 divided by 18. This test is greater than 4. Okay, so that means it's definitely kind of in your favor if you're well prepared. If you're not well prepared, you're going to sit and look at questions and not know how to approach them, and that's going to eat up your time. Okay. Incidentally, if that happens, what should you do? Move on. Okay, if within 30 seconds of reading a question, you don't know how to start it, move on. Okay, in fact, I recommend you read through the whole test and I number them. Okay, I renumber the questions. I go, that's the one I'm going to do first. That's the one I'm going to do second, because I'm sure I know how to do that one. Okay, I want to do the ones I know how to do first, because I know I'll get them done quickly, and I'll feel good because I'll be pretty confident that I know I've done them right. And then I approach the other questions better. Okay, if I don't know how to do the first question, I just sit there and stare at it for 10 minutes. I haven't accomplished anything, and it has stopped me from doing the questions I knew how to do. Okay, don't let a question you don't know how to do stop you from doing the ones you do know how to do. Okay, do the ones you're sure of first. No one says you have to do this test in order. Okay, I never do tests in order. Okay, not ever. Well, I shouldn't say that. Since I learned not to do tests in order, I've never done the test in order. Okay. All right, if there's no other questions, then what you should be doing for the remainder of class, which is 1 minute, is relax.